you were saying earlier in your introduction that you used to work at Vac, and then you did also work at Waku, which is the peer-to-peer zero-knowledge messaging protocol.
Yeah, it's like a peer-to-peer communication protocol.
It's not zero-knowledge.
No, but it's using zero-knowledge as well, and it's off-chain. So I mean, it's a lot of things I could say about it. I guess it started off like working on secure messaging, application called Status, and I think one thing we noticed is that the protocols that Ethereum provided us were like not sufficient. So we sort of started going deeper into like protocol research and like actually describing the protocols, not just like as a piece of code, but in terms of what the protocol does, what security properties it has, and basically creating specifications so you can have multiple implementations. Kind of a bit like Ethereum has multiple client implementations as well. As part of that, we created Vaku, and then it's basically like a peer-to-peer communication protocol. Back in the day, there used to be like with Ethereum, there was Ethereum for compute, and then Whisper for communication, and then Swarm for storage. That was like a long time ago. Only Ethereum sort of kept going at ETH, and then we basically took Whisper and turned it into Vaku. And the team's still going strong. Vaku is still around. It's being used by products like Railgun and the Graph and Portrait and stuff like that. And what we're trying to do is just make peer-to-peer work in like a privacy-preserving way, but also on resource-restricted environments. So from your browser and from your phone, without using kind of centralized gateways and stuff like that. And as part of that, we sort of got deeper into protocol specifications and actually describing like what are the properties we get and how do we compose these different protocols and so on. We also started using, that's how I got in touch with Barry Whitehead in the beginning, before, right around the time when he started PC, and he had these like crazy ideas of how to use this technology. And at first it was just like, oh, that sounds interesting, but I didn't quite understand how it worked. But as we dove deeper into it, then we did some experimentation and stuff. It became sort of from like this idea, a crazy idea, to something that's actually practical. And now it's being used in production. So specifically that was with RLN, which stands for Rate Limiting Nullifier. And it's a way to sort of get spam protection or Sybil resistance in a peer-to-peer network. So that's how I sort of got started with CK and stuff like that. But a big part of that was like thinking in terms of protocols and specifications first.
And how has it informed your sort of work on zero knowledge and privacy and cryptography nowadays?
I think one thing that's interesting about that as well is that it was more using the privacy properties of zero-knowledge proofs and not sort of the scalability properties. And it was also used in an off-chain context. And I think a lot of applications that are interesting are also happening off-chain. Like I think in terms of new ideas and so on, that's kind of a richer space to some extent. I think a big part of it is also in terms of just thinking in terms of protocols and specifications. I think there's like a lot of products in the space that they make some cool app or product or whatnot, and you can use it, but it's hard to understand how it actually works. And it's not always that different from like a Web2 company where you can just shut it down. You don't really understand the security properties you have. So I think it's really important that if you're trying to create like a protocol, that you actually think about it as a protocol. And that means having like kind of like IETF standards, like HTTPS, like how internet was built up, that's actually what you're doing. You're creating these protocols and they have certain properties, and you can have multiple implementations. And that's ultimately how you create sort of this modern infrastructure that survives, like Ethereum and all this CK tech and so on. It's not just like random products, it's like this fundamental infrastructures and standards that you can sort of analyze and that can survive the original operators of the application or product as you may have it.
Cool, great answer, thank you. That's the 101 right there.
That's the 101 right there.
So is this the top of the hike, or no, there's still more to go?
Yeah, just by this specific, it's like a little bit top and then goes down a bit and then it keeps going. So basically Taipei is surrounded, it's like in a basin, so it's surrounded by mountains. And yeah, we're on one of the ridges.
I see. But this is like where most people stop? Or?
Yeah, I think a lot of people stop here and then they go down, because this is like where the stairs stop and so on. We'll keep going for a bit.
Instagram.
Yeah, this is the Instagram spot, right? Yeah, exactly.